So, bearing in mind that definition that we have about filters, i.e. they take input, they process that input, they produce output based on the input, let's have a look at some very commonly used filters in Unix. I'll show you the table and I'll show you examples of each one. Well, I've listed 8 common filters there, starting with cat. Bet you didn't know that cat was a filter. At the top of the list, cat is the simplest filter of all, in that the processing that it does is, well, there's none really. It just takes the input and echoes that input back out to the screen as output, which I guess is a very simple form of processing, but I guess we could call it no processing. Down to the most complex and powerful of all filters that I know about, called awk. What sort of processing does awk do? Well, anything you want it to. We'll have a look at that in a moment. Anyway, we'll just go through them one by one. Cat first, very simple. I assert that cat is a filter, which means that you should be able to do things like the following. WHO, pipe to cat. Is that possible? Yes. Now the output that you see there is the output of the cat program, which is in turn identical to the output from the who program. Remembering, of course, that the only thing that cat does with its input is it echoes it straight back out as output. Now it seems a bit silly to use cat in that manner, and of course it is. You can also use cat to read input from a file, like another.txt, and so on. Or you can even, if you want to, use cat by itself on the command line. What's going to happen here? Well, of course, it's going to sit and wait for keyboard input. So, of course, I'd better type something. And it echoes it straight back out. Exactly what I typed, it just echoes back onto the screen for me until I type Control-D, at which point it stops. The next filter to show you is almost as simple, called more, which is a pagination filter. It does almost exactly what cat does, but instead of all the information being dumped onto the screen at once, it does it a page at a time. Let's have a look. I could type WHO and then pipe the output to more. Now this will hopefully allow me to see all of the users on the screen. There's the first page of them, and there's the second page of them, and apparently there's still more, and there's the remainder. Anyway, enough said about more. Obviously, you can say more a particular file. You could say more another.txt, and so on. grep is next. Actually, grep is such a useful filter that I'm going to devote an entire module to that. That will be in the next module. So moving right along, sort. Sort can be used to sort the output from another program, or it can also be used to sort the contents of a file. Let's look at both of those examples. We'll have a look at who pipe to sort. This time we'll get the information from the who program sorted alphabetically. Let's have a look at that. And well, we didn't get to see the first 25 or so results, but you can see that the rest of them are indeed sorted alphabetically, and you can see that I am indeed logged in on PTS1, which is about 6 or 7 from the top. If I wanted to see the entire list sorted one page at a time, can you think what I would do? Well, yes, I could do this. Who pipe to sort, pipe to more, which is using 2 filters simultaneously, each doing their own little bit of processing, and I get the first page alphabetically sorted, then I get the second page alphabetically sorted, and then a couple more at the end. Zexon, whoever that is logged in twice, as you can see. I can also use sort to sort the contents of a file. So I could sort another.txt, and again you can see that the output of the sort program is the contents of the file, but the contents sorted alphabetically. Note, and this is very important, if you ever use sort program with a file in this manner, note that the contents of another.txt have not been changed at all. It's not actually modified the file, it's just read the file, read all the lines in the file, and echoed those lines out to the screen in sorted order. A big mistake that a lot of people make is that they assume that sort actually went in and sorted the file. It's not true. Let's move on. Well, next on the list is WC. Well, you've seen that already, so I don't need to show it to you again. Next on the list is T, as in T intersection, which is a program that will take its input and write it to two places. It will write it to the screen, which can obviously then be redirected using the pipe symbol, and also write it to a file, or several files. I'll give you a brief example of that. I would say who, and then pipe it to T, and then I would put the output of the T into a file. So I could say call the file wholist. So all the output from who will be written into wholist, because that's what T does, and then I could send the output that T presents on the screen to say WC-L. I will get two sets of output from T. One will go into the file called wholist, and the other one would have gone to the screen, but I'm going to then pipe it to WC-L. Let's have a look at that. And I get 47 users currently logged in, and I can look in the file wholist to see who they were. So I could say more wholist, and there they all are. There's the 47 of them. And so on. Great. The last two, sed and awk, are quite complex filters. I could spend an entire chapter talking to you about sed, and I could spend an entire course talking to you about awk. Sed is about as complex as any reasonable text editor, while awk is as complex as any reasonable programming language. In fact, awk does indeed sport its own programming language. So I'm not really going to go into those in this particular chapter, or indeed in this course at all. I'll just show you a brief example using sed. Again, using the old who example, I just say who, there's all the users that are currently logged in. Now what I'll do is I'll take that output and I'll try and, in a really simple manner, format it into more user-friendly output. So I'll take the results of who and pipe it to sed, and I'm going to put a rather complex little argument to sed, which will be this. I'm going to replace all instances of PTS/ with terminal space, like so, and run that. Now you see the output, how it used to be PTS/46, for example, and now it's terminal space 46. Alternatively, I could use sed to remove all instances of people that have been logged in since May. I'll do that now. It would be who pipe to sed/May/D. And now if you look at the list, you'll see that there aren't any more people in the list that have been logged in since May. So that's a little brief example of what sed can do. A little bit of more interesting or clever processing than sort or grep or so forth. And awk, of course, can do absolutely anything. It could take one line of input and produce 30 pages of output, or it could take 30 pages of input and produce one line of output, or anything in between.